So moving on to question number 10, if the function fx equals given by this one is continuous at x equals 5, then the value of a minus b. Now this function is continuous at x equals 5, meaning LHL equals RHL equals value of the function at x equals 5. So let's start this question. Now when you go for LHL, you can clearly see the value coming is a multiplied with 5 minus pi plus 1, while from right hand side the value coming is b multiplied with 5 minus pi plus 3. Value of the function is also same as we obtained in left hand limit. Now simplifying, we need the value of a minus b. We can clearly see a minus b times 5 minus pi is equal to 2, or the value for a minus b is 2 upon 5 minus pi. Let's see from the given options, 2 upon 5 minus pi, that is option number 4 is the correct answer. Let's move on to question number 11. Let z from the set of complex numbers be such that mod z is less than 1 if omega equals 5 plus 3z divided by 5 times 1 minus z. Then we have to talk about real part of w or omega and imaginary part of omega. Let's start this question. Since omega is given to me 5 plus 3z divided by 5 into 1 minus z, just cross multiply so that we can write z as a function of omega. We have 5 omega minus 5 omega z is equal to 5 plus 3z, right? Now writing z in terms of omega, we can say z is equal to 5 omega minus 5 divided by 3 plus 5 omega. That's clear. Now it is given in the question that mod z is less than 1. So put modulus on both sides. Since mod z is less than 1, therefore mod of 5 omega minus 5 divided by 3 plus 5 omega is also less than 1. Correct? We can take 5 common, divide by the same and just square up to get the final result. So we can rewrite it as omega minus 1 divided by omega plus 3 by 5 multiplied with its conjugate, that is omega bar minus 1 divided by omega bar plus 3 by 5 is less than 1. This is clear. Just square up and we know that mod z square is z bar. So this gives us the result. Simplify to get the result now. This is omega omega bar minus omega bar plus 1 less than omega omega bar plus 3 by 5 omega plus 3 by 5 omega bar plus 9 by 25. Right? Now simplifying further, we can see these two terms are cancelled. We are left with 8 by 5 omega plus omega bar is greater than. What I have done, I have taken omega and omega bar on the right hand side. So we have 8 by 5 times omega plus omega bar greater than 1 minus 9 by 25, that is 16 by 25. So we can rewrite it as 2 times real part of omega, because omega plus omega bar is 2 times real part of omega, is greater than, this is cancelled, so we have 2 by 5 over here. So finally result with us is real part of omega is greater than 1 by 5. So let's see from the given options, we can clearly see option number 2 involves the same result. That is, as 5 times we can see real part of omega is greater than 1, right? Let's move on to question number 12 now. Let P be the plane which contains the line of intersection of the two planes given as this one, and it is perpendicular to xy plane. Perpendicular to xy plane meaning we can see that the ratio of normal, it is 0, 0, 1. Then the distance of the point 0, 0, 256 from P is. So let's plan the question. The required plane can be written as x plus y plus z minus 6 plus lambda times 2x plus 3y plus z plus 5 is equal to 0. Right? This plane is perpendicular to xy plane, meaning normal of this plane is perpendicular to normal of xy plane. So clearly we have coefficient of x from here multiplied with 0, coefficient of y from here multiplied with 0, coefficient of z from here multiplied with 1. So we have the result 1 plus lambda equals 0, giving us the value of lambda as minus 1. Right? Now we can write the equation of plane. Therefore, plane is, we write here lambda is minus 1, so x minus 2x, that is minus x, y minus 3y, that is minus 2y, z minus z cancelled, minus 6 minus 5, that is minus 11 equals 0, or x plus 2y plus 11 is equal to 0. Now question says find its distance from a point given as 0, 0, 256. Therefore, required distance, we can say, is equal to 11 divided by root 5. Correct? Let's check from the given options. 11 by root 5 as given to me in option number 4. Now it's time to move on to question number 13.